Good morning, students. So, welcome to our next class. Today, in our previous class, till now, we have taken an example of a tic-tac-toe game, and we have tried to design two algorithms, right? So, the program one or the algorithm one was very simple. Now, whereas in the second algorithm, now we have seen a little bit of logic, or we can say some type of rules or knowledge we have used, wherein which we have came up with the pass, win, go, how we can identify which move has been which move is going to make or which opponent is going to win the game, how you can block the moves. Now all this way we have tried to design the algorithm. So now continuing with that from where we have left, right? So this is the algorithm what we have seen in our previous class, which had uh, 9 turns. So uh, next, slightly we are going to change this. Now there is slight algorithm, another new way in which it can be done. Now in this particular program, now we are going to represent the board. Of course, we are going to consider the same board which has got 9 3 by 3 matrix, which has got 9 elements, but the representation is slightly different here. Now this is what the representation was made. Now how the representation was made is, now instead of considering, see, in the previous games or the previous data structures and all, now if you consider your 3 by 3 tic-tac-toe board, if you consider this board, so let me make a little bit thin. Okay, yeah. So now this was the position 1, this was the second position, this was the third position. Simultaneously like this we went the ninth position. Now here we are going to slightly change this. Now this will be the eighth position. Now this will be your eighth position. So next one will be the third position. So third, 4, like this, 1, 5, 9 and 6, 7, 2. The numbering of the board positions is being changed here. Now why we are changing the numbering of this board position such that when you take diagonally, vertically or horizontally, so now what is the number you are going to get? Now when you look properly this numbering, so now when you are going to find the sum, like say for example if you sum the first row, so what is the total you are going to get, right? So 8 plus 3, 11 plus 4, 15. Now you sum diagonally, so diagonally also you are going to get 15, right? Either horizontally, vertically or diagonally, when you find the sum you are going to get 15. So that means now you are numbering your board that produces a magic square. So all rows, columns and diagonal, the sum will be up to 15. So it makes easy for us to use the pause win. So in the previous algorithm we have used that algorithm while checking now which player is going to move. There what the confusion we had, or what is the generally the drawback when you consider the previous algorithm, was that the pause win method. So when you are taking the pause win method, now identifying 18 or 50 which player is going to win, how you want to block, so there are two different numbers, right? Now here we are just making this a magic square such that the sum adds up to 19. So it becomes easy for us to check whichever what will be our possible win. But now again there are certain drawbacks here. What happens, in addition to marking the board as move are been made, so when you are going to make one by one move, so when player 1 is moving, player 2 is moving, now we have to keep this particular marking. So we have to carefully look into that particular marking and try to check. Now how we are going to check whether a particular player is going to win or not? Now this is checked for a possible win for one player. Now we consider each pair of squares. So we are going to consider each pair of squares owned by the that player. Say for example in this position X is there. Now after a certain period of time here also X has made a move. Now these are the two positions, right? So these two positions, now if you look here, 1 and 5, so totally we are going to get 6. Now we consider the values, the pairs of the squares owned by that player, and compute the difference between 15, right? Difference between 15 and sum of the two squares, right? Now if this difference is not positive, or if it is greater than 9, so then the original two squares will not collinear and we can ignore. That means he is not going to win the game in the next move. so we can ignore. So this is the condition how we can try to slightly change our board position if you are going to make the board position. But again, when you consider this scheme also, now it also is not a straightforward approach. Again, representation and calculating, now all these things becomes a very tedious job for us, right? So comparing which row and how you have to scan, now all these are the drawbacks what you can find in that thing. So to overcome that, now there is the third approach is been done now, which we can call it as the third program 3 or the third approach, right? So now in this particular approach, if you see, so let us go into this particular approach. Yes, that is the final approach what we are having. Now if you consider this approach, now what is been done here, the structure of the data consists of board, right? Now here what we are going to consider, the data structure is one called as a board position. So what is that board position? A structure containing a 9 element vector representing the board. So just like in our previous algorithm, now here also we are going to consider a 9 element vector, that is a 3 cos 3, because it is a tic-tac-toe. We are taking example of a tic-tac-toe, and a list of board position that could result from the next move. So once you make a move, what all the board positions will be there, now we are going to have a list and a number representing an estimate of how likely the board position is to lead to an ultimate win for the player to move. Now here what we are doing in our third program is, now we are going to get one number which we call the estimation what will be the board position if you go in that particular direction. So we generally call it as some heuristic. So we will be discussing this particular method in more details when we go into our searching module. Now here, now what does the algorithm says? Now just right now we'll try to understand this algorithm, right? So now the more explanations we will be looking into our forthcoming sections. So here in this particular method or the final approach, you can see that how effectively we are trying to improve our the normal program and try to bring in the knowledge and try to represent the knowledge properly and try to use some artificial intelligence. Now how does the algorithm is going to work here? Now to decide on the next move, right? Now if I want to make a move, so what we are going to do, we look ahead at the board position. Now before you are going to make a move, so you try to scan, you try to look into all the board positions and you try to see that now if I go in which direction, that results for you a possible move for each possible move. So once you make a move, what will be the board position, and then we are going to decide now which position is best for us, right? Now say for example, now here already this like say this is the game which has been already started, right? So now let us say that now this is the game, now it has been started. So now player X has to make a move. Now before he is going to make a move, now what the X will do, or this the first player is going to do, is that now he is going to check various possibilities. Now see, he can place the pawn here or in this position or in this position or in this position or in this. So he has got 1 2 3 4 and 5 ways, right? 5 path we can say. If he is going to place X here, then O is going to make a turn. Now what will be the board positions? Now what will be the board configurations? And what is the best move? If he keeps X in this, will it be a best move for X so that he can win the game or he can make a draw, right? If this is the best move for X, obviously this will be the worst move for O. So it is vice versa. So this is what we are going to do. From current position, now what is the best position? Now to decide which of the set of board position is best, now the following things is been done. Now how are we going to decide that now that particular position is the best? Now first step what we are doing, now we see if we are going to win. Now if X is going to mark here, now I will see that now if I mark X here, am I going to win the game? Now if I am going to win the game, if so, call it the best, then I will call that this is my the best move and I give a highest rating for that, right? From here, see, from this board position, now there are 1 2 3 4 and 5 possibilities. Say 1, 2, 3, 4 and 5. Now the first position, how it will be, you are going to place x here. That means down here. Now I'll write this diagram for more clarification. Now what will be the possibilities here? So now this is already O, this is x, and x is here again. Now here O is there. Now he x can make a move here. Now if he makes a move here, is he going to win the game? Right? See if it is win. If so, call this. If he is going to win the game, then that will be the best move. Now otherwise, second step, consider all the move the opponent could make next. Now, if I am not going to win the game, now I will consider all the move what opponent is going to make. If I make a move here, right? Understand clearly. So from this step, now x has to make a move. He can make a move in this position, this or this. Now if he is going to make a move in this position, now what is the possibility the opponent can make a move? See, now opponent can make a move in this position. O can be written here, or O can be written here. Now O can be written here or here, right? Now O is having 4 alternatives. So now consider all the moves the opponent can make in the next move. Now see which of them is worst for us. Now out of these 4 moves what opponent is going to make, now you have to see that which will be worst for me. If I make a move here in the next level, so which will this move which I made it right now, is it going to be best for me or worst? That is what we are going to do here. Recursively we try to keep on doing, right? Now assume the opponent will make that move. So if you assume that okay, that move so he is going to make, so then we consider that as an we give the rating now based on the best or worst move. Based on that, now we are going to select this. So if you come to know that by keeping my position at this position, now this will be my best move, so then I will go with this. I may drop this and this position. Clear? So the third step says the best move is then the one with the highest rating. So which move is going to give the highest rating? Some numbers, some heuristic values we are going to give. So we use one function here, right? So now this method or this algorithm, now it is called as a min-max procedure or min-max algorithm. So we will be discussing this algorithm in detail in our forthcoming sessions, right? Now this is what we are saying here is that in this the final approach, before I make a move, now I will go to the next level and see what will be the opponent's move. If the opponent is going to benefit by making the move at this particular point of time, now or not, now we try to consider these things in this particular algorithm. So now this is the third approach what we have seen. Now out of all the 3 approaches what we have seen, so of all the 3 approaches what we have seen, now we can tell that the final approach is the best approach, because here we are using a min-max algorithm. Now where in which we are trying to use some heuristic or artificial intelligence, so that the game, the computer or the system, before it is making a move, it tries to look what will the opponent move next level. So what the opponent is going to make a move. So with that move, if I make a move right now, because of this move, whether my opponent in the next move, will it be a best move for me or will it be a worst move for me? So I am planning. So now you can see that this algorithm is better compared to all the previous 2 algorithms. So this is one example. Now what we have seen, that is a tic-tac-toe game, and how from the starting simple brute force method or a normal algorithm, you see how slowly we are trying to implement some knowledge, we are trying to implement some rules, some intelligence, we try to impose it into our program or in our system, right? Now this is the one example. So next we are going to look into another example. Now here we are going to consider another example called as question answering, right? So now this is the question answering. This is another example. It is a normal type of a paragraph and a questions, like how you have try to answer these questions in your previous elementary school or the degree level. So now what does it says here? So now we have a paragraph. So we are given one English paragraph. Now there are certain questions will be given for us. Now what we have to do is that now you have to answer these questions by reading the paragraph. This is a problem for this what we are going to consider right now. Now if you consider this type of a problem, now generally how we people are or how you people are trying to solve it, right? Now the one of the easiest method what we are going to solve is that when one paragraph is given and four questions are given, generally how we do, first we read the questions, right? I will take the first question. Now in that particular question I will identify some keywords in the question. This is normally what we are doing, but actually technically speaking we are not supposed to do like that. First you have to read the paragraph, understand the paragraph, then read the question. But generally now what we do, our first approach is that blindly, what is that common approach what we try to do is that now we read the question first. In that question we pick one or two keywords, then we take that keywords to the paragraph and we search where is that key, where is that particular words in the comes in the paragraph. Now wherever sentence that word fits, now we read that particular sentence and we try to extract that answer will be there in that particular sentence, right? This is what generally we are going to do it. So now let us consider this particular problem. Now what does this problem says? Now accept input in English. So we have one paragraph, we accept the input in English and provide answer also in English. So whatever questions are there, now we have to answer. Now this problem is slightly harder. Now it is slightly harder than the previous one, as it is more difficult to specify the problem properly, right? Now here we have to understand the English. So it might be correct, sometimes it may not be correct, depending upon what type of paragraph you are having. If the paragraph is very simple, now it is easy for us. We read the question, we get one or two words, we search that word in the paragraph. But if the questions are twisted, indirected questions, then you cannot find it easily. So for that you have to read the paragraph first. So it is not an easy problem. Now we will try to look into the one example. Now here what does the example says that? Now this is the paragraph given for us. Now what is the paragraph says? Now Rani went shopping for a new coat. So a particular person is going for a shopping to buy a coat. Now she found a red one she really liked. So she found a red one she really liked, and when she got home, now she found that it went perfectly with her favorite dress. Right, this is the paragraph. Now generally what I told, we are not going to read paragraph first. First we read the question. So what is the first question? Generally how we are going to solve this? What did Rani go shopping for? This is the first question. So we will pick two words here, important words. Rani, shopping. You go to the paragraph. So where is there? Okay, here Rani is there, shopping is there. So this and this are matching. Right? Now I read the sentence. Rani went shopping for. See, what did? I got my answer. Answer is new coat. So what did Rani go shopping for? I will directly write new coat. This is how we answer generally, right? Next what we are doing. Now I don't read next sentence. I will read the next question first. What did Rani find that she liked? Right? Now again Rani is there. Something like find, liked. I will go here. Now she found. So here found is there. Here find is there. Some grammar little bit. Okay. So then a red one she really liked. No, liked here the word is coming. Now in our question also word is coming. Now I will read. We will come to a conclusion that answer is somewhere in this sentence. Now I will read the sentence completely. So she found a red one. So what did Rani found that she liked? A red one. That is red color coat. This is how we are going to answer. Clear? Now take the third question. Did Rani buy anything? In our normal way how we are doing, did Rani buy anything? Now we'll take few words like did Rani buy, okay, two three words. Now we'll start scanning the paragraph. So Rani is there, but nowhere in this sentence buy is there, right? Buy is not there. I'll go to the second sentence, again buy is not there. Buy, brought, purchased, nothing is there. I'll go to the third sentence which says that when she got home she found that it went perfectly with her favorite color. Here also there is no word which gives the meaning for this particular word by. So that means you cannot answer this question. But if you read carefully, if you apply your intelligence, it is indirectly given that when she got home means what? Actually, she is buying this coat. She brought this coat, and when she brought this coat to home, then she found that it is matching with her favorite dress. But you cannot answer this question, right? Like we can answer if you read the paragraph first, but our normal approach, how we are doing, reading the question first, right? Now based on this, now we are going to use a method now which is called the method 1. So what is our first method? What we told, reading the question first, then trying to answer. This is the normal program what we are going to understand here. Now what are the data structures we are going to implement here? So what this program does, now this program attempts to answer the question using the literal input text. It simply matches the text fragments in the question against the input text, right? This is what we did just now, we have discussed. Now what are the data structures we are going to use? Here we are going to use two important data structure. The first one is called as question pattern. Now we are going to have the question pattern because we told first we read the question, not the paragraph, right? So we are going to read the question first. So we are going to have something called as question pattern. Now what is that question pattern? Now we will try to design or make or write some set of templates, question templates. So we try to frame some set of templates that matches the common questions. So our question has to match with this template. Now we will write some 3 to 4 templates we will make. And what we do, we take one template and we see whether this template matches with any of these questions first. And for each of these question templates, we will be having some patterns. We will be having some patterns will be there. Like say for one template of question, I might be having 2 or 3 patterns will be there. First, if this template matches with any of the question, then I will take the pattern, right? I will take the pattern which is associated with this template, and that pattern I will try to search in my text or in the input text. This is how we are going to do it. So a set of templates that matches the common question form, and we produce patterns to be used to match the input, right? We'll be having templates, and for each template there will be certain patterns. Now we try to match that text patterns, which is called as the text patterns. Now these text patterns are paired so that if a template matches successfully, right? Now let's see here how we have done. See, if this is my example, or this is the question, so let us come here. This is what we are going to do it, right? So okay, we'll come to that once we'll define the data structure. We'll come to that. So now what it says that we have templates and patterns, two things. Templates, set of templates which should match with any of our questions. Then for each template we'll be having text patterns. Like say for example, now we write one template. So what is the template? Who did XY, right? So who did XY. So now I take this template, I match with any of the input questions. Let us come to our questions. Now what are the questions? Who did XY, right? Now this is our template input. Now you see who did XY template, it matches with 2 questions here. The first question, who or what, right? Did is there. XY, see X I can substitute for Rani and Y, right? Here also X Rani is there, Y. So now if you look carefully, now this template who did XY matches an input question, right? Now for this template I will be having some text patterns. So like text patterns XYZ. Now we are going to match this XYZ is match against our input text. Now in input text I am going to match who did XY. If it is matching, then this Z will be the answer. So I am going to pick up this Z is the answer. The value of Z will give me the answer to this question. This is the one data structure. Next is of course the text question. So input text will be having, so that will be your the question. Now, what is the algorithm? Now, how the algorithm we are going to write? So, what is the first step we are going to do? Compare each question of your question pattern. Right? You have got certain patterns, question patterns or template you are having. Right? Now, you compare each element of your question pattern against the questions. You have questions is there. You have some templates are there. Question templates. You compare it with your questions and use all those that match successfully to get set of text patterns. If this template matches with the question and corresponding to that what all the text patterns are there, you try to generate the text patterns. Then second step, now pass each of these text patterns through a substitution process. So keep on substituting the the patterns with the text whatever it is matching. Now generates an alternative forms of verbs, so that so we try to generate some alternative forms. Now so that for example go in the question might match with went in the text, right? In text went will be there, but in our question go will be there. There will be slight difference. Now you have seen here also, like you are saying what did Rani go, so here go is there in our question, right? Now here went is there, correct? Similarly, what did here find is there, here found is there. So there is a difference. So we will try to generate all alternative forms of verbs. Right? This will be done in our second step. Now third step. Now we apply each of these text patterns to the text. Now we apply it to the text and collect the resulting answer. Right? Now if you are not got the answer, again fourth step, reply with the set of answer just collected. So once you get the answer, you reply that, otherwise you select another text pattern. So like say for example, now based on this algorithm, I think it is very clear. So based on this algorithm, now we will take one by one question. So we will take a template, what did xy. So we see that now this matches with our first question, right? Now this what did xy template, it matches with the question and we generate the text patterns. So what are the text patterns you are going to generate? So what will be replaced? Substitution process we do it. So right, so the substitution process we do it, Mary or Rani go shopping for Z. The pattern will be xyz. So what did xy? So now what did xy? So Rani or Mary go shopping for. So now after the pattern substitution step, now this pattern is expanded to set to a set of patterns, including we expand it. So what all the we can do it? So we will replace. Now one pattern will generate Mary or Rani goes shopping for Z. Rani went shopping for Z. Like this, various verb forms, alternative forms of verb we try to generate by using substitution method. 2 or 3 we generate. Now once you have generated all this pattern, now we will go to our text, the given text paragraph. Now we will search. Now anywhere this Mary or goes shopping for is there, or Mary went shopping for, which one is there? Now if you look here, what is there? Mary went shopping for is there. Mary go is not there, right? But alternative we have generated two alternative. One is Mary goes and the other one is Mary went, but this is matching. So this is matching, Mary went shopping for Z. Now where this Z is there after for, so went shopping for new coat. So now that will be answer. We assign Z the value a new coat and we will define this as our answer, right? Now this is how we are going to get the answer. Now so you take the second question. Now just like our first question, the second question is not like that. So what is our second question? What did Rani find that she liked, right? So now this template should be very large here. So now the insertion of an object, see find is there. So now find is there between now it and modifying phrases. So phrases like she liked. So now you are going to insert find. So the between this. So what did? So she find it. So we are going to insert some new phrases into our template such that the template matches with our question. right? Then you generate the alternative forms. So you are going to generate the various alternative forms and you try to get the answer. This is how we are trying to do it. So like that, she liked, or really she liked, or she found, all these different alternative we are going to generate. Now if you take the third question, now did she buy anything? So now you cannot answer this question, so you cannot answer the third question, because now when you try to look into the template what we are having, what did xy, and when you look into your question, so did xy, nothing, it has been matching here, right? So directly you cannot answer this particular question by this method. So whatever the method right now we have found, now this method is easy for us, it is a straightforward method. Now only if it is applied, if our problem or if our paragraph is very simple, if the paragraph is very easy and it is very simple, so then this particular method is easy for us to apply. Now otherwise, so now the method is very difficult for us. So even though this is a very simple approach, primitive approach, but basically it's not matching the criteria where we are saying the set for intelligence. So when we are saying an intelligence, like in games, in tic-tac-toe, how we used, how to block an opponent, this type of intelligence we are not using in this particular approach, right? Now there is another approach to overcome this. Now we'll go for another approach. Now what does this approach says? Now here, now we are going to use the concept of English grammars. Now this particular program, or the program 2, or the second approach, now converts the input text into structured form. Now you are going to convert the input text, your paragraph is been converted into some type of representation, some type of a structural representation, such that you can extract some meaning from the sentences. Now it also converts the question also into that form. Now we want one particular knowledge representation form, right? See now, so now to understand this particular example again, now we are going to use some type of knowledge representation, which again we will be discussing that in our forthcoming sessions. So now what we do, now we try to use some kind of representation form, both your input text as well as your questions are being represented in that particular form, and it finds an answer by matching the stored forms against each other, right? Then by using matching we are going to find the answer. Now again here we are going to use the data structures. Now what are the data structures we are going to use? First is English knowledge. Now we are going to describe words, grammars, and semantic interpretation of all these. Now you are going to build one small dictionary type. So you are going, based on the paragraph, what type of a paragraph, based on the domain, right? You try to have some words, some grammars, appropriate semantic representation, right? You try to keep all these things and try to build a knowledge of English, so that your entire sentence is been converted into that particular representation, right? So you first build one English knowledge. So now that knowledge contains all the words, so that it can, you when you process this, you can compare that thing, the knowledge. Next you will be having input text, right? Now this input text also is converted into this particular knowledge representation. So firstly what you do, you should have one knowledge base, so like some small dictionary you are going to keep. Then you have input text, then you convert that into a structured text, right? Some knowledge representation, some knowledge representation method you are going to use, right? So we try to use certain representation, because so when we are talking about English, you know that there will be verbs, there will be the nouns, pronouns, etc. There are so much of complexity involved in our English language. So now we need some knowledge representation scheme is being required for us. So now if you look here, now there are various different type of knowledge representation systems are there. So now all these knowledge representation, now we will be discussing Now when we go into our next module, so when we go into our the after our searching module, so when we go into our the next modules, now there, now we will be in detail discussing what is a knowledge, how the knowledge is been represented, different forms of knowledge representation. Now when you look the various forms of knowledge representation, like say we have something called as production rules. So production rules, so it will be in the form if x then y. Now already, now we have discussed in the previous class, right, when we have when we have taken the chess game, representing that chess game, right, we have seen that if x then y, this is one type of a knowledge representation called as rules, production rules. Similarly, we have got slot and filter, uh, and we have got mathematical logic, right, we have got scripts, we have got frames. So all these we will be studying in our forthcoming modules or in the other chapters. But right now, now you see that we have different type of knowledge representation, and we are supposed to use this. Now for this example, now they have selected one type of knowledge representation which is called as slot and filler system. Now in slot and filler system, now say for our first question, right, if you take our first question, so for that particular, this is not, I think this is your second question, right. Now if you take our first question, now for that, now this is an example how it is been given in terms of slot and filler structure, right. Now here like event, so we write, later we'll come to know what is the slot and filler structure and how you are going to represent that particular way. So you will be discussing later, but right now understand, you will be having something called as event. Now instance, now finding is an instance, finding is an instance, liking is an instance, like this we try to write. And tense, so past tense, so finding is past tense, right. Here liking is also a past tense. Agent, who is the agent here? So Rani, right, in our example Rani, the name, the agent, noun, what we are taking, agent is Rani. And object, right now we are going to just take think one, so this is one for event. Like that we are writing another alternative, or we can say various things, liking, past, modifier, so much. Object is think one. Now when you consider this object think one, for this object, what is that instance? Instance is a code, and for every object there will be some attributes. What is the color? Red. See, you see that in our paragraph, so you have red coat, Rani, find, right. So like this we try to keep it in one way of representation. Now this type of representation we call it as a slot and filter. So the questions are being stored in this particular representation, and we try to get the answer. The paragraph also is being represented, right. Now what algorithm, now what we are going to use here, we convert the question into structured form, right, like this. So we convert the question into this type of a form, slot and filter, or production rules, or scripts, or frames. So in any knowledge representation, you convert it first, convert the question into that knowledge representation. How you are going to convert? You are going to use that data structure English know, or English knowledge. By using that data structure, you convert the question, right. So then use a marker to indicate the substrings. So we are going to use a markers like identifying or searching, like who or what she found, who, like that. So of the structure, now that should be written as an answer. If slot and the filler system is used, a special marker can be placed in more than one slot. So once you know the slot and filler structure, you will come to know. But right now you can just understand that now we have the questions, you convert that question into one type of a knowledge representation, right. Now such that it becomes easy for us to match all the words, it depends on the noun or a pronoun or the verbs and all those things. So then what we do, the answers will be appearing, we can identify the answers by matching this structured form against the structured text. Then you try to match this with our input text, right. So we try to use this particular method. Now when you use this method like slot and filter structure, and by using that events and the things, objects, who is the agent, So still first and second answer you can generate easily, but to answer the third question again it is very difficult for us because there is no direct response, right? So there is no direct response, even though this approach, now the second approach is more meaningful than the previous one and is more effective, but we need still extra additional searching time. We need more time in our database to have the get the answer. So why this the third question we are unable to answer by using this method also? Because the English knowledge base, when you are considering the English, the grammars which are being used in the English, now it is very complicated. Even though we have just 26 alphabets, but still the grammar is very complicated, right? Now especially in handling the pronouns, pronouns it becomes more difficult. Now let us see an example why. See, for example, now Rani walked up to the salesperson. Rani goes, she goes to a shopping, right? She is going to a shopping and she walked up to a salesperson. She asked where the toy department was. This is one sentence. Let us take this one sentence. Now take another sentence. What the sentence is? Now Rani walked up to the salesperson. This and this is same, right? Now see the second one. Here she asked where the toy department was. In the second sentence you see she asked her if she needed any help. Now you see the complexity involved here. Now if you are going to substitute this she for Rani, right? See here, see Rani when walked up to the salesperson, she asked means when you go for substitution, when you want to try to get the questions for your answers, right? When you are going to search for the patterns, now here she you are going to replace it with Rani. Now similarly, if you take this particular sentence and if you replace this she with Rani, so then this becomes wrong. Now here you see here what this statement is telling. She asked her. Here she means we are talking about the other salesperson. Here the for salesperson we are using the pronoun she. Here it is used for Rani. See, this is what the complexity involved here. So in our original text, when you are going to link, when you are going to substitute she to Rani, now it is easy, right? But when you take this sentence, the complexity changes. If this was there in your text, you can answer, but if this is there, you cannot answer for your question. So that is what we are saying, the complexity is more, so we need some additional knowledge also, right? So to overcome these type of pronouns or handling these type of a knowledge, now we go for another structure. So we don't use the slot and filler structures like this. Now we try to represent our knowledge into another type of representation, now which is called as a script, right? So which is called as a script. So this is the third way in which we can try to solve this particular answer. Now it is called as a script. Now you can see here, this is an example of a script, how we are going to write the script, how we are going to draw the script. So in our later section in detail we will be discussing what is a script. So now here we can see C enters L. So C is what we can say customer, right, or a consumer, depending upon our problem. Now you can see, so you can see here in this example, when we are talking about scripts, you will be having roles, you will be having props, you will be having locations, so all these things. So when it is a shopping, so we are taking role as customer and salesperson, C and S. Now later on for this C, for this customer C, you can substitute it as Rani. When you replace it with Rani, so then she is entering, right? She enters. So now this is the entire the drawing, or we can say the representation, now wherein which now we can try to represent the knowledge and try to answer all our three questions by when we are going to consider these scripts, right? So right now don't worry about this, what is this diagram, why, how it is looking. It is a very simple thing. We will be discussing that in our later sections when we go for knowledge representation. Right, now this is the second example now what we have considered. Clear? So this is the two examples right now. Now what we have seen, so one is the tic-tac-toe game and other one is now we have seen the our question answering. So now we started with our content in our previous class that we want to understand 4 to 5 questions. We studied what is our underlying assumptions, right? Now we discussed what is the assumptions, now what is an AI technique. Now similarly we'll go and we'll try to discuss now what is the level of modeling we want to apply, right? So what is the level of AI model? So to what level we want to model our AI system? So now what is our question here? What we want to understand? Now our goal. What is our goal? What is our goal in trying to produce a program? That means when you are going to build your system, are we going to build your system that do the intelligent things that people do, right? Level of modeling, to what level of modeling you want to do our things. When you want to build your system, to what model you want to build, that is what the definition of AI, right? Already we have seen how do you define an artificial intelligence. You are going to define that you want to build a system which can do the things which at this moment of time human beings are doing it in a better manner, right? So now when you want to build an AI system, when you want to model a particular AI system, now to what level you want to model it. So now here, now two things comes into our picture here. First one is, are we trying to produce programs or systems that do the task the same way that the people do? Are you going to do the task in the same manner how the people are going to do it, or are we trying to produce program that simply do the task the easiest way that is possible, right? No need of applying any AI. Is, are you really want to apply artificial intelligence and do the task that the system wants to do the task, or you want to model the system which does the task better than the what peoples are doing, or you just want to do the task in a simple way now which is possible, right? So now this is what we want to understand. Now in the first type of things, what we say that we want to attempt to solve problems that computer can easily solve and do not require AI technique, right? So now we don't require any AI technique, just the computers can easily solve it. So no need of any intelligence is required. So which it can try to solve. So AI technique, when we are telling AI technique, already we have seen, so AI technique, it uses the search. So one of the important parts in our AI technique, first is search, the second is our knowledge, the third is abstraction. This is the three important thing. So AI technique, if you don't use any searching, so if you have got no direct method is available, and use of knowledge on the object involved in your program area, right? And the abstraction. So if you just want to solve a problem just because it helps us with our machine, our computer is very fast, without using AI, can you build your program? Or really you want to solve some of the problems which is better than what human beings are doing, right? So what actually we want to model, what level of intelligence we want to model. We don't want to design a normal program which computer can do it in a better manner, like say for example searching. Now if you want to search 1,000 records manually, it takes lot of time, but if you apply some searching methodologies, now you can search it very fast with the help of a computer. See, that is the difference, because computer is a very fast machine, so you can search it very fast. Because since computer system has got certain characteristics and you want to use it to solve a problem, or really you want to solve the problem by using AI technique and model it to a level wherein which the program or the system does better than human beings, that is very important. So we have so many examples wherein which the AI has been used. Like say for example, we have got elementary EPAM, that is elementary perceiver and memorizer, so which was being used by psychologists. This is one particular type of program which is being used. And similarly, when you go for another program called as PARRY, which is used in the for a paranoid person to identify the behavior of a particular paranoid person, or to answer the question answering, just like how the newspaper is trying to do it. So these are initially some of the programs which has been, which was what you say, having AI intelligence, or the, you can say, the level what they have been done. So initially they use for general problem solver. So this is the another things what we want to understand. So now to say that if your model, you are going to build an AI model, so which uses the intelligence, so what is the criteria for the success of that model? So the criteria of success is Turing test. If it is passing the Turing test, then only we can say that yes, so you have built a particular system. I think already in our previous class also we have discussed what is a Turing test. Now in 1950 itself, Alan Turing proposed this method for determining whether a machine can think. So how do you determine that okay, the machine is able to think, the machine has got some artificial intelligence? Only when if the machine is able to pass the Turing test, then we can say that it has some intelligence. So right, so what is that particular Turing test? So already we have discussed, right? So there is a particular person A. Now he is, you can act as an interrogator, right, like an examiner, external examiner, who is going to ask some viva. So he asks some questions. Now in the other part we have, one is X, another one is Z. But this examiner, he don't know that this is a machine. He thinks there are two persons in front of him, both are not visible, just in one side he's typing some questions. So now he also answers the question, and the other person also answers the question. Now if the examiner get confused in the sense, if he declares that so I got the correct answers from both the persons, then this has passed, because this is not a person, it is not a human being. Now he don't know that it is a machine. That means machine has tried to cheat him. Actually it is a machine, but this examiner, he is thinking that it is a another human being. Now we say that the machine has passed the Turing test now, because it has got some intelligence. So the main goal of machine is to fool the interrogator, fool the examiner in believing that it is not a person. So then we say that our criteria of success, that means if it has passed the Turing test, that is what we call it as a Turing test. I think it is clear. So this is what we have discussed till in this particular class or in this session. So in the next class, now we will be discussing about the problem space and search, because now we have studied already now what is AI. We have seen some simple definition of artificial intelligence, right? So we have taken the some examples, and we have seen from the normal example to the building the knowledge representation, right? In the first tic-tac-toe algorithm, we have seen why searching is very important. In the second example, we have seen why knowledge representation is very important for us, right? So in the next class, now we are going to look into the how to define a problem, right? Now if you want to solve, whether it is tic-tac-toe or in question answering or a chess or any problem, so in the second module we will be considering various examples. But before you try to write some intelligence program, first you have to define the problem. So how you are going to define the problem? Now what is the state space, and what is the searching? Now all these things now we will be trying to discuss in detail in our next class, next forthcoming class. Okay, so I think in this in our 4 classes now we have covered quite fundamental things. From our next class onwards we will be going to the problem definition, so which is very important. So in the example also, in the examination also, you will be getting a few questions, very important questions and we'll be trying to deal how do you define the problems, right? When you consider a problem, how to define it, what is state space, what do you mean by searching, what are the rules we are going to apply. Now all these fundamental things we will be discussing in our next class. Okay, till then, take care of yourself. Now have a nice day. Bye bye for watching, and request all of you to subscribe my channel also, so that whenever I am going to upload the videos, so you will be getting the notification. Thank you. Have a nice day.